This slide we started with our discussion with the microprocessor. We start with the architecture, then we go for pins and signals. So as for the architecture is concerned, it is a 8-bit microprocessor and it could access 64 of memory. Then most important aspect, and this slide what I tell is very much important as per all till the end of this course. How that operations are doing and how you will know about the information. So microprocessor initiated operation, internal data operation, and your external peripheral initiated operation. Now that microprocessor initiated operation is the important part, that is memory read write to or IO read write. To do this, it has to identify the peripheral, enable the peripheral data transfer. So these two slides you have to take care. This slide and this slide, it should be keep in your mind every time it is written. So that the process, how that operation is going on, little in discuss now. Will summarize this thing completely. Then these are the instructions. Different architecture is there. So there are so many. ALU is there. ALU is associated with one temporary register and a flag register. So what is the job of the flag register? Can anyone tell? What is the task of the flag register?
Sir, it gives information about the data like the sign, the parity, and other things.
The thing is that it will give you the status. It will give you the you have done one operation, arithmetic operation or logical operation. After doing that operation, what is the status of the result? That means if you do addition, if the result is 0, then the flag will indicate that the result is 0. If you are having a sign operation, whether it is a positive number or a negative number after the result, it is reflected by the flag. That means flag is indicating the result what you have done the operation in this set a result according to the result of the operation. That is important. So ALU is doing all the operations. In addition, whenever ALU is doing all the operation, it will operate on a 2-bit of data, whether it is 8-bit of two data for the addition or subtraction will be there. So one of the data must be stored in where? Accumulator. Accumulator is the main part in your operation. One of the operand must be stored in accumulator, and after doing that operation, result will be definitely stored in the accumulator. That most important things you have to take care of. Accumulator is one client, and after the result will be after the operation, result will be stored in the accumulator. So accumulator is most important. Okay. Then instruction register is there. It will receive the instruction from the memory, then decode that accordingly to do the next operation. Okay. So in the flag, in the register, how many different registers are there? General purpose, special purpose. General purpose क्या है? B, C, D, E, H, L, and it is 8-bit. 8-bit data can be stored in B, can be stored in C. But if you require to store the 16-bit, you can club B and C, you can store 16-bit. You can club H and L. So these are the combinations. You cannot club B, D, B, E. You cannot club B, D. You have to club B, C, D, E, etc. So the combination of HL is an important part. What is the job? Can anyone tell? Have you remembered that? HL का एक स्पेशल काम है. क्या काम है वो? It will store the 16-bit address. That is any content in HL pair indicating to a particular memory location or address of that particular memory location. Okay. So that is clear in our when you go for instruction. Okay. Then it is come program counter. Program counter, it is a 16-bit register. What it holds?
It holds the address
of the next instruction to be executed. Okay. And stack pointer, it holds the address of the top of the stack. ये एक नंबर या दो नंबर का क्वेश्चन आता है. What is program counter? What is stack pointer? According to the size of the or mark of the question, you have to write something. Then another, it is address bus and data bus is there. So when it is address bus, what is the size of the address bus? It is 16-bit and data bus is 8-bit. So now these are the things we already covered. Then we will go pins and signals. Out of the pins and signals, important part is there are 5 sections of सुनाई दे रहा है मेरी बात?
Yes, sir.
Can you able to listen to me? Okay. So the entire set of signals are divided into 6 groups. पहले तो power supply and clock frequency, because to operate that microprocessor, you have to provide a VCC, that means 5 volt, and a ground must be there. Clock frequency must be there for operating. What is the clock frequency required for 8085? How much frequency required? What is the clock
3
frequency required?
megahertz.
3 megahertz. But it is divided by 2. You have to provide a 6 megahertz, and it will divided by 2 internally, give us 3 megahertz required frequency for the operation. And another thing is that it is address bus is there. The size of the address bus is 16 bit, data bus is 8 bit, and control and status signals are there. So these 3 in numbers, the group of 2, 3, and 4, it is helpful in the bringing the inside the microprocessor and do the processing. So that is the microprocessor initiated task killing if you चाहिए. So for microprocessor initiated task is that either it is a memory read or IO read. Okay. So when you do the
Yes, sir.
memory read, what you have to do, you have to identify the location from where you have to retrieve the data. To identify the location, address bus is required. To enable that data, you have to go for your control signal. When you have to enable, whether what is the meaning of enable? That means if you want to bring the data or store the data, that information must be provided to that IO device or memory. So that means you have, whether you are going to read or write the data, that control signal must be given to that IO device or memory. Clear? So when it is come for your, after control the signal, when you enable that device, then you can bring the data with 8-bit data bus in the microprocessor. So why this 8-bit, as the 8-bit data bus is there and address bus are used at the beginning of the any fetching process, after that there is no address bus is required. So out of that 16 address bus, 8 address bus used as well as address and data. It is a time multiplexed. So let me show you one figure in the that one. Please, can you visualize this last figure? Is this figure? So please look at here. This is a 8085 microprocessor. A8 to A15 address, higher order address bus is available here, but AD0 to AD7 is available through a latch. Okay, this latch is controlled by a enable signal ALE. One type of tri-state it is. One type of tri-state. What is the job of the latch? जो आप देंगे वो यहाँ पे मिलना चाहिए. ठीक है? So what will happen now if this ALE, what is the function of the ALE? Address latch enable. When it will act as an address, so it will latch means when it is ALE is high, these things will be available as address. When this ALE is low, it will act as an data. Okay. So this is the clear picture of demultiplexing of 80 to 87. So out of that 16 address lines, 8 address lines are used at time multiplexed 80 to 87. So initially it will act as an address bus because during the first clock cycle of any microprocessor initiated operation, your identification is required. So you have to fetch that signal. For fetching purpose, you have to use your address bus. That's what is A0 to A7 it will act. After that, when you identify the location, when the control signal is given for data transfer, same address lines will be used for data bus. But when these lines are used at data bus, this will be active low. When AL is active high, enable will enable that. This will be the address bus to be available. Getting my point? So ALE is the controlling when this 80 to 87 will act as an address or when it is act as an data. So it is control that ALE. Now compare. After that ALE read write मैंने आपको बताया था read क्या है? So it is a control signal. when you are identifying a location, whether data will be read from that or write to that location, it is given through a control. Okay, so status, whether that status signal will give you indicating that it is no operation over that, but it will help in showing the what operation you are doing, what is the status of that operation, whether your microprocessor is doing a memory operation, whether it is doing an IO operation, or whether it is a read, write. These the things are given by the status. Status is there, S0, S1 in the pin is there. If it is 0, 0, no operation 0, 1, it is, and it is 0, it is a memory write, 1, 0 is memory read, then it is memory IO write, IO read. If it is 1, then it is 0 will be output test. I will tell you what is this things detail next class or today, I don't know. Then you come for reset and reset out. Now these as things, your doubt was Mr. Mishra, this one, hold HLD ready by
No, sir.
Mishra.
Yes, sir. Yes.
So these are microprocessor. So these are the three tasks it is given. One, it is microprocessor initiated operation, when then it is your internal operation. Third one is that what is it is called microprocessor. Yeah, the last one, external.
External and peripheral.
It's a kind of exactly external initiated operation. That means these are called your external initiated operation. Okay. So external initiated operation means this is an input pin. Input means someone is giving input to the microprocessor. Externally it is initiated. Okay. If you want to reset your microprocessor, that means if it is reset, what will happen? All things will stop. From the beginning it will start. That means the program counter will come to 0. Starting. Then hold pin. What is hold? मैं आपको लास्ट क्लास में बताया था. मान लीजिए माइक्रोप्रोसेसर is there, one IO device is connected, external IO device and memory location है. IO device चाहता है कि वो डाटा ट्रांसफर मेमोरी को करे. How it will do? It will give to the microprocessor, then microprocessor will transfer to the memory. Every time the IO device or external device or any system want to transfer or getting the data from a memory location, it has to contact the microprocessor. Agree? Without the intervenance of the microprocessor, the IO device cannot communicate with the memory. Agree? But there is a controller that is called your DMA controller. It will help that. How it will do? It will, if a DMA controller is connected, the IO devices will be connected to DMA controller. Then DMA controller will send a request to the microprocessor through hold pin. Hold pin का मतलब you just hold your operation. Please give me the system bus. System bus means address bus, data bus, and control bus, so that I can directly transfer some data from this IO device to the memory with quick success. Every time ये path microprocessor होके जाता है data, तो it will too late. It will time consuming. So to improve the performance, what will happen? A controller is connected which help in transferring the data from IO device. Let me explain you this board. So now this is microprocessor 8085. Then it is another controller will be there. This is the memory. What will happen? They will connect to hold pin. When the hold pin is connected, the system bus will be given to this. Then using this system bus, it can directly transfer the data. That means at that time microprocessor do some internal operation, but the system bus will directly transfer this. So directly memory can be accessed. That's what this is called a DMA controller, direct memory access. So to do that DMA operation, direct memory access, this must be, it has to give a input signal to this hold pin. So when you are receiving a request, when the microprocessor receives a request on this hold pin, what will happen? It will, the acknowledgement must be given. When you are getting any information, you have to acknowledge. When you are receiving a parcel from a anyone, you are giving your signature that acknowledge that you have received that. Similarly, when microprocessor receives this hold signal, it will give an acknowledgement to the XLDA. This is an output signal, and it is indicating to the that which is requesting hold that please wait, I am doing some work. When I will complete the current task, I will give you the system. So this is called your hold and HLD operation. Okay. Then ready क्या है? The signal is used to delay the microprocessor while cycle. That means मान लीजिए there is a operation, a data transfer is occurring between a microprocessor and memory, but the memory which is connected is slow. The operating speed of that memory is not as fast as the microprocessor. What will happen? It will send a signal through this ready pin that I am not ready, please wait. Okay, so that means the slow responding peripheral gives a send to throw this ready signal to the microprocessor for do a synchronization operation. So when this ready pin is high, that means it is ready. If it is low, it is not ready to transfer. Getting my point? Yes. So now come to interrupt. Interrupt are, let me tell you that board. So what is the meaning of interrupt? First thing is that whenever last class I told you, you are writing some program code. You want to blow a light here, and after that you want to blow a light. A 20-second gap is required. So when the microprocessor is writing a program or executing a program, this light will go. After completing this program, the certain program will return next to blow this one. But during this, if you want to gap a 20 second, you have to engage your microprocessor in some other task. Microprocessor को off तो नहीं कर सकते ना. You cannot stop. You have to engage this microprocessor by writing some code in some other place, and you have to, in between these two programs, where to light 1 and light 2, you have to make the microprocessor available here. That means you have to interrupt this microprocessor from doing this operation and making available here to do it here. This is one type of interruption we can call. That means we are moving the execution program counter value from this location to this location. These are one example of your interrupt. So there are different type of interrupts are there. Let me tell you. So now, to interrupt, that means what you have to shift the microprocessor direction or microprocessor operation from one direction to other work to do. It is doing some list of work, but you divert the work and you are making it available for the other work. Now we are taking the class in a classroom. If somebody will know, then our study will stop and we have to divert to that direction. Okay, but we have to see what type of interrupt is there. Whether this interrupt we can stop or we cannot stop. If a bunch of student is coming, it is maskable. We can stop them. We wait there for 10 minutes, or we wait for the end of it. If another teacher is there, okay, who can please wait? Just I am finishing. I am coming. That is also maskable. If the BC will come, then we cannot mask. He has to enter into the class and whatever you want to tell, you will tell that. Getting my point? So that means the interrupt is two type, maskable and some is unmaskable. Getting my point? Which is maskable, which is unmaskable, clear. So two differences are there. So some interrupt are maskable, some interrupt are non-maskable. Okay. So there is a interrupt, it is called trap, TRA. It is non-maskable. You cannot mask. If any interrupt is coming from trap, so that means it is a powerful interrupt when it is coming, when there is a power failure is there, when there is a very damage to the processor is there. At that time, when the situation is out of control, this type of interrupt are coming. So this is called your non-maskable. You cannot mask. You cannot suppress that interrupt. When it will come, you have to allow that and you have to stop that. That is called your on-mask. Others are masked. Okay. Out of that maskable, there is a and it is vector and another is non-vector. Vector मतलब क्या है? Vector means in simple mathematics, what is the meaning of vector?
It has direction.
Direction. That means particular direction पे हो जाएगा. If it is not vector, it will random direction, any direction you can assign. So from that meaning, we please come to that. So RSP 7.5, 6.5, 5.5 are vector interrupt. If you look at this slide, it is written vector interrupt. उसका मतलब क्या है? In your microprocessor, if the interrupt is coming from RST 7.5, the microprocessor will go to a particular location 0024 in your memory to do the operation. So that means a specific task is written at 0024 when you interrupt to that. That means simple thing. अभी मान लीजिए अभी ये आप कुछ बोल रहे हैं आपके डिपार्टमेंट में कुछ क्लासेस गोइंग ऑन पे स्टूडेंट्स ऑफ bunch of students come from electronics department. Why? Definitely they will come and do the announcement of their activity there. That is a fixed job they will do. Getting my point? So that means if any interrupt is coming from 7.5, it will going from 0024 fixed location. If it is 6.5, it is going 0036. That means a defined set of bunch of program is written at that point. Microprocessor will stop its general execution for list of execution. It will directly go to this location and do that whatever the task is. If it is going there, it will do the task. Getting my point? That means it is vector and it is a fixed program is written in that particular location, that thing will be executed. So this is not user friendly. So only thing is that now come for another, it is that INTR. INTR generally interrupt is one type of, it is written in terms of program. Hardware interrupt where it can be any location. It is not a vector. Any location it can move. That means if it is interrupt, that means you have to go for I will write call 3600. It is a software interrupt. This is hardware interrupt. Let me tell you after that we will go. So that means INTR is not a vector interrupt. That means in that location when you are getting an interrupt, you can go for any task. If somebody is giving interrupt through INTR, it may be for transfer of data, it may be for any operation, anything. Any request can be, you stop this operation, please do task for me. Okay, this is called your non-vector interrupt. So, what are the different? One is maskable, non-maskable, clear?
Yes, sir. Yes, sir.
Then it is vector and non-vector. Non-vector means इस defined location पे जाके काम करेगा वो. अपना normal execution बंद करेगा, defined location पे जाके काम करेगा. Okay, that is vector, non-vector. Another it is your hardware and software. Software means you are writing a, just like for the light blowing, it is a software input. That means you are writing a program, 1, 2, 3 program for blow the bulb number 1 and write 3, 4, 5 program to blow the bulb number 2. So now this is bulb 1, bulb 2. But in between that you have to write call 3000. That means when the call 3000 instruction will be executed, microprocessor will move to a new location 3600 to write whatever the program is. To write, make it is in a loop for 20 seconds, and then after that it will make available to execute the next instruction. So now first is blow, then is interrupt, then second program. Okay. So now come for that side. So these are the are there. Please look at here. Maskable, INTR, these are maskable, but trap is not maskable. You cannot do mask. Then vector, INTR is not vector, all are vector. And another hardware and software. So after that, serial input pin is there, serial output, nothing is there. So this is so these are and so I have given you some few questions of previous year in that notes. Please check that.
Yes.
Have you gone through that? So try to practice that one. If you have any doubt, please get it back to me. I will try to solve. Okay. So next class tomorrow. These are the overview of what we have discussed till now. Next class we will go for instruction, how that microprocessor is functioning. Again, we will focus on this. This one. Again, we will start from this slide. Every class will start from this slide only. Okay. So that means again we will dive in detail what will happen in each step to execute one instruction and what different type of instruction, how much time is required to execute any instruction. Okay. So we will go for simple things. Okay. So next class we will meet on Wednesday 10 o'clock. Okay.